it's kind of said that there are two different types of differentiation or taking the derivative. It's either explicit or implicit. Explicit is kind of like it explains it. It says y equals this, and it's all x's. That's explained. That's what it is. Implicit is it's kind of implied. There's some y. I don't really know what it is, but it could be in there. Is kind of how that goes. And so these right here are, the first ones here are explicit. It's just y equals this, and you see how there's only one variable over there. Then the second one, s equals 5t minus 3. There's only one variable on that right side that you can use, and it's solved for the other variable. That's explicit. Or the other way, u is 7w squared plus 33. Those are all explicit because it's solved for that variable, and there is only one other variable on the other side. Right? That's pretty straightforward. Implicit is when you have just stuff all jumbled all over the place. For example, the first one is x times y equals 3. Or the next one, x squared minus 2y to the third plus 4y equals 2. And then it gets worse, right? Then at this point, there would be a really good question. Some of them that are given to you implicitly can actually be changed to explicit. If you ever have that chance, I would suggest you do that. Looking at those that I gave you implicitly, you could write them all explicitly, but which one's probably the easiest one to actually write the way up above explicitly? Yeah, the first one. How would I get that to be, and we kind of like x to be the variable that's on the other side. So how would we got x times y equals 3. All you have to do is do what? Divide by x, right? So I could change this one, and it would come up here to be y equals 3 divided by x, right? So sometimes you can do that. Are we going to want to try that with something like this? You know what? By the time you do all that, you're going to be so tired, you're not even going to want to take the derivative, or you're going to forget to take the derivative by the time you get there. Okay? And then this one, yeah, forget it. All right? Don't waste your time on that. We're going to take a look at another way, and basically this is what we're going to do today. How do you take the derivative of those last two I underlined? How do you do that? Okay. Now, one thing that's kind of, do I say it now or not? Maybe we'll wait till later. So here it says differentiate with respect to x. That's a lot of what we do. It's either x or time normally is what we differentiate with respect to. And so I don't know why I did that down at the bottom, maybe to see if that bothered you. But so really, here's what you're doing. It's just you've been leaving something off for a very long time. Okay. So this is something, is the derivative of that overly difficult if it is with respect to x? Not really at all, is it? It's just power rule, right? You take 2 times 3 is 6, x to the first. And really, I could have been making you write this the whole time. Is it the derivative of x with respect to x? Well, how come I haven't been having you write that? Well, that's kind of understood. Because what is dx over dx? 1. So do you need to write it? Is there anything different I can put in there? Not really. Okay. It's the derivative of x with respect to x. And so this is something that we kind of say, you know what, we really don't have to write that. Okay. Could I have had you write that whole time? Yeah, but it'd just be a pain, right? So now this next one, I am taking the derivative with respect to x, but it's not an x. It's a y. The nice thing is you basically do the same thing with one very small difference at the end. So let's go ahead and let's take the derivative of this. Let's pretend it was an x for now. If it was an x, you would just take the 3 times the 2, right? Agreed? So it's 6, y to the... Do you agree? That's basically power rule, right? Power rule is still power rule. But what did I do? I took the derivative of y with respect to x. That's a slight problem. Why is that a problem? Because we don't even know what y is. Y could be anything. Could be some weird function. Could be something very simple. We don't know. Do you see how here we took the derivative of x with respect to x, right? Here we took the derivative of y with respect to x. Does that just cross off like that other one did? No, it doesn't, does it? So you know what? For right now, this will be good enough. Yeah, for right now. We'll get to that. We'll get to that. Don't worry about that right now. The question is where's that equal sign that we've been having so far? Basically, is your question, right? And we're not worrying about that. I'm just trying to get you to get the idea down first, and then we'll deal with the equal signs. Yep. Because you have to have this concept down before I want to throw those in there. All right. Believe it or not, that does make it different. So this one is the derivative of all of this. That's what this is saying. Take the derivative of all of that with respect to x. Well, there's a plus sign there. So is this product rule? Should I try that here? No, that's just addition, right? So just do it as if, just kind of pretend they were x's, but they're not. Well, that one is an x. So what's the derivative of that? Now, technically, I could make you write this, right? And some people do for a day or two when they do this implicit, explicit stuff. They write that for a day or two, and then they kind of get it all ironed out, so they don't have to. Plus 3, right? Just pretend it was an x. The derivative would be 3, right? But it's not an x. It's a y. So dy over dx. Now, here's an interesting question. Can I add those two together? Why not? Because that's 1 times dx dx plus 3 times dy dx. Are those the same thing? No. Okay. Is it okay, though, to say that, for our purposes so far, that that's the answer? Yeah, but you can't get rid of the other one. Uh-oh. So I'm saying take the derivative of all of that with respect to x. Could I turn around and say do it with respect to y, and does that kind of change things a little bit? It does. It changes things a little bit. So you have to make sure you know which variable you're trying to take the derivative with respect to. X is the best because then your derivative in your original, the x value, travels. What do we got to do? Product rule. So let's write down the first one. X times the derivative of the second one. You can just pretend for a while it's x. 2y, but let's not forget something very important. dy over dx, right? How come I didn't write dx dx on this first one? Yeah, I didn't take the derivative. That's why I didn't write it. I didn't write it because I was lazy. I didn't write it because I didn't take the derivative. Plus, write down the second one. So should I write dy dx on this one? Why not? Yeah, I didn't take the derivative. Okay, and then got to take the derivative of the first one, which is, and again, if you want to, you can get in that habit of writing it. Some people, it really helps them remember the dy dx if they write the dx dx. There's not a whole lot you can do now. I mean, I can multiply this if you want. So 2xy dy dx plus what? Really? Y squared. There you go. So implicitly is kind of what we're doing here. We're saying it's kind of like a chain rule, but we don't know what y is. We're saying, yeah, I know I have to take the derivative of that y, but I don't know what it is. Yes? Yeah, 2xy, 2yx doesn't matter. And really, you could put xy2 if you, it really doesn't matter because it's commutative, but we're just not used to seeing it that way, right? Yeah, so 2yx, 2xy, it doesn't matter. Yes? In the blue there? So in product rule, you were told to write down the first function, right, which is x. So I wrote it down. But the key is why I didn't write dx dx. It's because I didn't take the derivative. I just wrote it down. Then you have to take the derivative of y squared, but just pretend it's an x for now. So do you agree that would be 2y to the first if it was just like that? But then I did take the derivative of y with respect to x, so I have to write it down. Exactly. Well, that's why some people write it down no matter what they do, so that then they can see, oh, can I erase it or not? Well, dy dx you can erase because I don't know what that is. Okay. Plus, and then you write down the second one, right? Y squared. How come there's no dy dx on that one? The y squared. I didn't take the derivative. I just wrote it down. Okay. Where did the 1 come from? Yeah, derivative of x, right? And that's dx dx. Well, then how come down here I just have y squared? Well, because I know what dx dx is. What is it? It's 1. Times 1 times y squared is y squared. Right? So that's why I strongly recommend, until you get the grasp of this, maybe to write dx dx in there so that you know when you should write what. Say that again? Right, because this top D here was saying take the derivative of all that stuff with respect to x. That's what that notation means. Are we good? Just in general? Implicit? All right. Oh, well, that one looks familiar. X times y equals 3. Oh. Huh. Well, you could. We're actually going to do it both ways. Well, should we or should we not? Let me think. Maybe if we have time at the end of class, we'll come back and do this one the other way. But I would strongly recommend, if you have a chance to write it explicitly, to do so. Does this one take a whole lot of time to write it that way? No. We did that already, right? Y equals 3 over x. But if I were you, I would write it even better than that so that we could take the derivative rather quickly. Or y equals 3x negative 1, right? Now, technically, let me show you. This is what I decided I wasn't going to tell you before. You've been doing implicit this whole time. I just haven't told you. We've always been taking the derivative of the left side, haven't we? And it's always been with respect to x. I just tell you to put y prime, right? What's the derivative of y? Let's just pretend it'd just be 1, right? dy dx. You've been doing implicit the whole time. You've just been writing it as y prime. I've been hiding that fact from you. Okay? So you take the derivative of the left. There it is. All right. Equals negative 3x. Now be careful. Negative 2. Again, you can write y prime here if you want, but I'm going to show you now. You've been doing it. So dy dx equals, that just means a derivative, right? Well, negative 3 over x squared. Yeah, we got time. Let's do it the other way. Here we go. We're going to do it the other way. I'm going to show you that they come out to be the same thing. XY, what do we got to do? Product rule. Do we have a question? Okay. So product rule. So write down the first one, which is x. Derivative of the second one. 1. dy dx, right? Now remember, over here, what could you have written right here? Dx dx, right? But again, you're just so accustomed to not doing that, you didn't even do it. So over here, so now we have a plus, right? Then I'll write down the second one. Nope, no dy dx, very good. And then 1. Technically, if you wanted to, you could write dx dx, right? Equals, so did we take the derivative of the left side? Got to take the derivative of the right side then. 0, all right. See, took the derivative of 3, there it is. Just a constant, doesn't get anything. It gets hosed. Because there's no variable. So here we go. If we multiply this out, we get x dy dx plus what? Really? Y. And at this point, can we get rid of the dx dx now that we've seen it? Right? We know what. Equals 0. Well, wow, those two don't look at all alike. But the key when you take derivatives is you want to get dy dx by itself. Because when you do it explicitly, that's why explicitly is so much fun. Because how hard is it to get dy dx by itself? It's not, because it does it on its own. It's right there. It's done. But here we've got to get it by itself. Can we still do that? What would you probably do first? minus y from both sides. Divide by x. Okay, so over here it says that the derivative is negative y over x. Over there it says it's negative 3 over x squared. Well, that's something else. And here's what I'm going to leave open for extra credit for tomorrow. If you don't get it, I will show you. Show me that those two are the same. No. The question was, can we just put an equal sign next to it? And no, you can't. You have to algebraically show me. And I would say do it individually. You can each get points for this. It's not first come, first serve kind of extra credit. You need to prove to me that those two derivatives are equal. Yes? The first way we did it was explicitly, technically. We rewrote it as y over 3 over x, and we wrote y equals 3x to the negative 1. But you have to take the derivative of both sides. But so far, when you take the derivative of y, what have I been having you write? Just y prime, right? But you agree y prime and dy dx are the same thing. But I showed you here, if you take the derivative of that with respect to x, the derivative of that is 1 dy dx, right? The reason explicit is so much easier is dy dx is all by itself already. You don't have to do any more work. But here, we had to take the derivative here. And again, you could have put dx there. But you're just so accustomed to not doing it that you have it. Okay? And so then I just cleaned it up. Because the only thing that actually had a negative 2 power on it was the x. So that got put back on the bottom. Okay? Well, the middle one's still the derivative. It's just not in a form that's going to be helpful when we start doing algebra with it. You know what I mean? You're going to want it in this bottom form very, very soon. You're going to want to be able to get it to that form. And I'm telling you right now that these two are the same. The red and the black are the same. And for tomorrow, for extra credit, prove it to me. Now, it's not that hard at all, actually. Calculate the derivative with respect to x for all of that. Hey, that looks familiar, too. Ooh, evaluate the derivative at 0.20. So 0.20 is a point where? Just some random point I chose and felt like it? Or it's a point on, yeah. Do you know what the graph of that looks like? I kind of do, but I'm telling you that if you put 2 in for x, you're going to get 0 for y. But I want you to evaluate the derivative, so I'm asking you to find the what at that point? Slope. So is that instantaneous rate of change or average rate of change? Instantaneous at 2,0. Well, let's take the derivative of that darn thing. Here we go. Now, we could try and solve that for y, like we did the last example, but I think we'd be here too long. And then we'd forget we were supposed to take the derivative anyway. Okay. Here we go, derivative. 3, well, I should probably move this over, huh? Or I'm going to run out of room in a big hurry, I think. Here we go. So 3y squared, dy dx, very good, plus, now this term, very good, 2y dy dx. Basically, to answer the question, the point of this is so that we don't have to solve that for y. And we can still take the derivative. Because unfortunately, things in nature don't come in nice little formulas that are linear. Yes, this does get used. Huh. Just calculus. It's very much the same. It's still a derivative. It's just we're lazy. We don't want to solve that for y. So some mathematician said, yes, I'm going to be lazy, so I'm going to find a different way. Well, I can erase at least one thing up there. if I wanted to. That's that. Yeah, we don't need that. But your goal is to get dy dx by itself, but there's a ton of them. There's 3 of them. At least they're right next to each other. We got that going for us. But that negative 2x doesn't have one of them, does it? Yeah, we probably should get rid of that, huh? Move that. Get that out of here. Let's move that thing to the other side. So add 2x over to here, add 2x over there. And so we've got all of this stuff over here. I was going to skip a step on you there, but I think that I will not. Do you agree that's what we get? Why move it? Obviously, I pointed it out to you that it didn't have a dy dx. So then you said, well, move it. Well, obviously, what was the point of that? But dy dx isn't by itself. It's got all that junk attached to it. What do all 3 terms have in common? Factor it out. Could we factor it out with that negative 2x hanging out over there? No, you can't factor it out. That's in the way. It doesn't have a dyx on it. You gotta get it. So here, we can factor it out. Well, hey, then there's only one of them. Well, that's awesome. But what's left? A 3y squared. Because I took it out of here, right? What's left if you took it out of there? Oh, plus 2y. Minus 5. It's still not by itself. So good try, but we factored it, but it's still not by itself. Do what? Divide by what? Yeah, divide by all that junk that's in the way, right? Sound effects optional when you do it. So dy dx equals that. And because I don't have any more space, I can't really circle it very well. But dy dx equals that. And in a second, when I know everybody's done, I will just erase that and move the dy dx over so you can see it. Okay, so I'll give you a second to write that down. That's your derivative. And trust me, if we were solving for y, we'd still be solving for y. If we wanted to do it explicitly. Much faster. In fact, about 15 minutes from now, we'd still be solving it for y. We're almost done. That's the derivative. Is everybody good? Can I erase that and move it over? Yeah. Now we'll just do this. Well, I was going to move it, but then I realized I'd probably move everything, and so what's... So there is your derivative. But it's not the answer to this question. Well, it kind of is. It says calculate the derivative. We have to put in 2 for any x you see, and put in 0 for any y that you see. So dy dx, 2 times y2, just because it matches the other 2? No, it's x is right there. Y is right there. Put it in. Over 3 times 0 squared. Well, we really don't care at that point, right? Plus 2 times, oh yeah, we don't really care about that one either. Minus 5. So the derivative equals 4 over negative 5 at 2, 0. What's that mean? Yeah, that's your instantaneous rate of change or your slope. And is it okay to write negative 4/5? Mm-hmm. Yeah, 2, 0. So there is a rather interesting graph right there that you've never seen, but you just found the instantaneous rate of change on it, but you've never seen it. And remember, definition would be awesome with that one. That'd be loads of fun. Yes? Zero in for y. It's a y value.
Because it's y, it's 3y squared. So wherever there's a y. Wow.
Yep. 2, 0. Not an interval. That's an order pair. So now you should be experts at this. And you should be able to help me through this one. Solving for y, yeah, don't do that. Oh, wait, I'm sorry. I was reading, yes. I think I may pick people because some people haven't really been paying attention this whole time. And it would be fun to say their name and then have it record and go back and record what they say. And then I could send it to their parents and be like, this is how much they pay attention during calculus. All right. So I was told 2x should be the first thing I should write down. And again, once you get used to this, is that something you can probably forego? It probably is. But seeing this is the beginning for you, I suggest that you write it because then it will remind you to write the other one, which is the important one. Which really you've been doing this whole time. I've just hidden that fact from you. Very cleverly, I might add. Minus. So, yeah. Yeah, very easy dy dx to forget there. Very easy. I'm sure I've done it myself. And I've got you started. I would like you to get the derivative. Well, technically that is the derivative, but get the derivative in the form we're used to normally seeing it, and then please evaluate it at that point for me. And I will walk around it and see how you're doing. So those listening to the recording, please stop and actually do that, because I'm going to just pause it. Okay. For those listening to the recording, wondering why in just a second here the handwriting will be slightly different, we have a guest writer. So we've basically kind of taken the derivative, it's just not in a very clean form at this point. Okay, that's fine. Okay, so dx got crossed off. It's just 1. 2x got moved. Makes sense? Maybe I should not have had a guest writer because the handwriting is better than mine. Okay, factored out the dy dx, probably a good idea, because we don't want more than one of them. Yes, a slight assist there. So there's a much, the question that I just had is, should we simplify it? You can, but if you know ahead of time that you're going to be plugging in points or substituting in points, might as well just wait. Especially, you know what I mean? It's completely up to you. If I ask you for the derivative, most definitely. If I say, give me that derivative, that's all I want, then clean that up. Or you can just wait until you substitute in the points. It's fine. It's kind of, it depends on where you know you're going. You know? Because I think it's easier to almost simplify after you put the values in than it is before. And at this point, of course, she's going to simplify, because we might have to give that rule a name after a particular student. Yeah, and so if you simplify, you get negative square root of 2 over 2. That's very well done. The key is to get all the dy dx's on the same side, because they're all just dy dx. It's not like they're squared or cubed or anything. Just get them out there, factor them out, get everything else out of there. And there you go. Again, why do we use this? Really, what's the reason? Because we don't want to do what? We want to solve for y. Okay. Or to use the definition, for sure, we don't want to do that. And so that's why we use implicit, because it's way quicker. It's a little strange the first time you see it, but like I said, if you think back, really, you've been doing it. Just the easiest version of it, but you've been doing that one for weeks now. Okay. Well, a job, well, there's lots of jobs that you could possibly use this for. And again, I keep going back, what if we just stopped teaching all of this stuff? Would we ever have any advancements in anything? No. Okay. You're finding a rate of change. In fact, if you really want to know, I'm studying something now that